Hi, welcome again to our second tutorial regarding with the application of the second law of motion, which is the law of acceleration. So this time we have given up with another set of problem. Let me read it first for you. So a force of 5.0 Newton accelerates an object by 2.0 meters second squared. What force is needed to give the same object an acceleration of 3.4 meter per second squared? So this is our problem. So we need to analyze our problem first. So we are given up with the force, which is 5.0 newtons, acceleration of 2.0 meter per second squared, and another acceleration of 3.4 meter per second squared. Knowing our problem, we need to gauge our understanding regarding with the concept. What law is satisfying this equation, or what variables has been associated with this problem? Okay? So redefining the law of motion, the law of acceleration, it states that when it comes to force of an object, F net, or force of an object, is directly proportional to its acceleration. Tama? So what do you mean by the term directly proportional? When the force of an object increases, the acceleration of an object also increases. That's our concept. Both variable will goes up. Neither both variable also goes down when one changes from other form. Okay? Dealing with that, we need to look for our given. The first step is to analyze the given in a problem. Okay. So in our given, I will draw again a column and a row. So we have here the acceleration, given acceleration, and we have also the given meter per second squared, and we have given the force of an object. So the first force is 5.0 newtons with the acceleration of 2.0 meter per second squared. And let me write it properly. Sorry. I mean clearly. For a while. So we have 2.0 meter per second squared. On the other half, we also have the force of an object, or the unknown is, what is being asked in the problem is what force is needed. So that is our problem. And that is what we are looking for, That's what we are looking for our problem at this moment. So 3.4 meter per second squared is the second acceleration. Okay. So dealing with this type of problem, we need to analyze it first. So sabi natin directly proportional. So from 2.4 meter per second squared, it becomes 3.4 meter per second squared. What happened to the force of an object? 5.0 newtons. This analysis will never come up because we don't think how many fold increases in a certain variable. So medyo mahirap natin i-predict, no? If we're looking for it. So 2.0 meter per second squared to 3.4 meter per second squared. So kung titingnan natin, hindi siya kalahati. So kasi 2.0 dapat, kung 2.0 yon, kung kalahati yung idadag sa kanya, it should be 4.0. Pero hindi. It's only 3.4. Almost 75% lang ang nadagdag. So therefore, yung force na 5.0 newtons, almost 75% din dapat ang madadagdag sa kanya. From 5.0, nadagdagan siya, then therefore, hindi ito bababa, but magdadagdag din tayo dito sa force na to. Let's try to find out the answer by unplugging our formula. Let me do this first, the unknown. Please take note that I'm following the GUFSA pattern in solving your problem. Given, unknown, formula, solution, and the answer. So for our unknown, we are asked for the force of an object. Our formula Since our relationship is directly proportional, thereafter, our formula should looks like a so we talked about force and acceleration. Thereafter, we have F1 over A1 is equal to F2 over A2. So this will be our formula since we are dealing with direct relationship. Okay? So moving on, plugging on the value. So F1 is 5.0 newtons over our acceleration 1, which is 2.0 meter per second squared, is equal to F2, which is unknown. Instead of x, I will write F2. Divide by 3.4 meter per second squared, which is our acceleration. Okay. Next, we need to perform cross multiplication. So this one should be multiplied here. So 2.0 meter per second squared multiplied by our F2 is equal to 5.0 newtons. Let me rewrite the value of newtons, recalling that 1 newton, I am recalling the equivalent value. 1 newton is equal to 1 kilogram meter per second squared. Okay, do not forget. So this is very important in understanding the cancellation of units. So instead of newton, I will write kilogram meter per second squared. Multiply by 3.4 meter per second squared. Right? So I need to multiply. Right? So 2.0 meter per second squared multiplied by F2 is equal to 5.0 kilogram. 5.0 kilogram multiplied by 3.4. The answer is 17. 17. We are looking for the force of an object. 17 kilogram dash meter per second squared dash meter per second squared. Dalawa. Okay? Next, we need to divide both sides of the equation in order for us to arrive to the value that we are looking for. Okay, so 2.0 meter per second squared, I need to divide it by 2.0 meter per second squared. 2.0 meter per second squared. So this is cancelled because it appears on both sides of the equation at the same time. So F2 is equal to meter per second squared cancel, meter per second squared cancel. 17 divided by 2.0, the answer is 8.5. 8.5. Is it kilogram meter per second squared? Right. Kilogram meter per second squared. Or, our equivalent unit, our F2 is also equal to what? Is also equal to 8.5 newtons. Okay? Let's recall our concept regarding with this. So 8.5 newtons. Let's plug in within our row and column. Let me do this first. Okay. So sabi natin, we have here 8.5. newtons. So from 3.4, 2.0, 5.0, it becomes 8.5 newtons. So that's how we solve a problem that involves the law of acceleration, particularly when we are referring to the variable of the acceleration and the force of an object. Again, the acceleration of an object is directly proportional to the mass of an object. Or sorry, to the acceleration of an object is directly proportional to the force of an object. When the force is greater, it's also the greater acceleration needed in order for the object to move. Okay? The same value for the acceleration is needed for the F net of an object, causing it to accelerate. Is that clear? Okay, so thank you very much, and that's how we solve a problem that involved the variable of acceleration and force of an object.